There are no rectangular shapes in nature, but since the times of ancient Rome, most multi-story houses have been built in the Cartesian coordinate system. This is especially true for industrial mass large panel and volume block house building. If a vertical sheet of paper is held by its lower corners and imagined to be a panel of a multi-story building, it will bend, losing its stability, but if it is even slightly bent, it will hold its shape without bending. Similarly, if a reinforced concrete wall panel is curved in plan, its load-bearing capacity will increase dramatically and a substantially taller building can be constructed. Such curved walls can be placed along the perimeter of the house, not in the Cartesian, but in the three-beam coordinate system, and we will get a new unusual structural structure without right angles. It is divided into separate rooms with the help of radial partitions or walls. This is the proposed Lotus house building system, allowing economical construction of both high-rise and low-rise houses. Prefabricated reinforced concrete structures are a casting technology. The first creator of large panel house construction, Raymond Camus, used it, but the very design of the multi-story house was taken on the basis of ancient Roman buildings. But if casting, it is possible to cast products of other shapes. In the system Lotus, the main prefabricated element is a cylindrical volume block and an additional trapezoidal slab, or, if there are transportation constraints, curved in plan wall panel and a round slab. They can be manufactured on special molding equipment at house building plants, or, in case of small construction volumes, directly on the building site. Curvilinear steel form plates are rigid and can be much thinner. Transportation and installation of Lotus products is even easier, as the walls are stable and can be transported on conventional automobile platforms. In the Lotus system, it is also possible to build individual residential houses efficiently. Such houses are characterized by their unusual appearance. There are no high loads on the walls, but, due to the rigidity, the curvilinear walls can be extremely thin, and this makes them economical. The use of thin reinforced concrete allows you to build fast, capital, durable, fire-resistant, earthquake-resistant houses with a minimum consumption of material. It is easy to organize air heating, providing a low cost of construction and making them competitive with other structures. In earthquake-prone areas, it can be the salvation of the population from natural disasters. Capital houses of this type can be out of competition in terms of production cost. It is possible to organize the technology of prefabricated reinforced concrete production on site or on the landfill and transportation of prefabricated elements, which in the panel version are within the transport dimensions. Prefabricated reinforced concrete gives the structure of individual residential houses, Lotus, capitalization, fire resistance. Curvilinear walls allow to easily adapt it to almost any seismic load, both due to the stiffness of the walls and due to the creation of a monolithic frame in the grooves, if necessary, according to the parameters of the house. Curvilinear walls significantly increase the stiffness of the building, and floor slabs with curvilinear contour redistribute seismic forces and are stable against mixing. Perhaps earthquake-resistant construction is the main purpose of such houses. Curvilinear walls themselves are stable, so the installation is simplified and there is practically no welding work. The floor slabs are supported on a complex contour and can be assembled without welding in non-seismic zones. The thermal performance of the building may vary depending on the climatic region of construction, since the external insulation walls are independent of the load-bearing structures. Any type of facade can be used, ventilated, wet, simply three-layered, including with a brick-facing layer. An important innovation is the use of air heating for individual dwelling houses, which is possible due to the presence of slots in the outer walls. A diesel heat generator can be installed in the boiler room to heat the air. Vertical ducts are created by the construction of the building, and horizontal ducts are laid under the floor of the first floor. This design of the house favors the introduction of air heating, which determines the innovativeness of this solution. The rest of the engineering systems are traditional. Houses of this type can be produced with the use of 3D printing, if you work out effective inexpensive compositions of wall material and provide an acceptable finish of their external wall surfaces. In the future, 3D printing can be widely used to create furniture for such houses, which will give new opportunities for unusual interiors. As another example, an individual residential house with an area of 150 square meters is presented. The house is two-storied, which makes it possible to place it on a minimum-sized plot. The concrete consumption including the foundation slab is 4/10 of a cubic meter per square meter of area. Such a result is difficult to achieve with other construction methods. Other types of individual houses based on the Lotus system can be developed. They can be very different in appearance, area, and number of stories. Predominantly they are houses with flat roofs. The roof can be exploitable. Houses can be for one family, but also for several families. This type of houses can be built in the southern regions. Structurally it is the same Lotus system, but the difference is in the insulating materials. Naturally, the southern climate also affects the arrangement of the appearance of the house and garden area. Their small cost price allows you to increase the living space for the same amount of money. The most unusual in these houses are the interiors. It would seem it is not quite acceptable for an individual house, but if you think about safety in earthquakes and other natural disasters, then in combination with the low cost of construction of such houses increases the feasibility of building such houses. First of all, they may be in demand in seismically dangerous areas. Kindergartens can also be built in the Lotus system. The peculiarities of their design are related to the adaptation of kindergarten technology in the three-beam structure, Lotus. In principle it succeeds. Kindergartens are most often built with a limited budget. Such kindergarten is a finalist of the Gardens of Prytany competition. Since the three-ray structure is quite rigid, the increase of the kindergarten is achieved by replication of buildings, which can be side by side and united. The principle of large rooms such as a music hall, a swimming pool on an exploited roof or just an upper floor in other structures is also used here. Decorative appearance allows the construction of various buildings, including office buildings, cafes, restaurants.